Also note that here I've changed this y to an x. That was a typo. But it doesn't change the concept that if I double my input, I double my output. Let me note a correction here where this IO should read as IS. So in other words, your KIS, where IS is your input, yields an output IO. So that's just a typo shown here that I made earlier. I'll next describe the unit output method. In this case, the unit output method is an analytical technique based on the proportionality property of linear circuits. Here, the method involves finding the input and output proportionality constant K. So that is, we take this K, which is really the output variable over the input variable, either voltage or current, and here we assume the output in our first step is equal output of 1 volt or an output current of 1 amp. So in other words, we assume a unit output involving this. Now this unit output method is useful for ladder circuits such as this, and notice I already put VO is equal to 1, and then we're going to work our way back to our input voltage to see what input voltage will provide us with an output of 1. So in our second step, we need to find the input that will give us an output of 1. And here we continue to apply KCL, KVL, and Ohm's law. To find that input. Once we find that input, then we apply this K equation, a proportionality constant, output over input, such that our output is 1 and we want to figure out what our input is for a unit output. Once we figure that out, then we can find the output for any input using VO is equal to KVS, or Y equals KX, where X is the input, Y is an output. Now let's analyze this circuit. Here we assume VO is equal to 1. This is a ladder type circuit in which this technique is useful, this unit output method. Since we know that VO is 1, then we can use Ohm's law to calculate IO, shown here. So IO is just 1 volt divided by 20 ohms, which is equal to 0.05 amps. However, the current through the 10 ohm resistor, shown here, is equal to the current IO. So the voltage across here, assuming the current in this direction, then we'll say that this is V, this is minus, and we'll call that V1. So therefore V1 is equal to 10 times, so which is equal to 0.5 volts. Therefore the voltage across this 15 ohm resistor, which we'll call V2, minus here, and that's V2, is the voltage drop across here and the voltage drop across this 20 ohm resistor. So it's V1 plus VO is equal to V2. So V2 is simply equal to V1, which is 0.5 volts, and plus VO, or 0.5 volts plus 1 volt, which is equal to 1.5 volt. Now that we know this voltage across V2, and we know the current through it, which is just simply I2, we'll assign a direction here since to be consistent with our polarity, I2 is equal to 1.5 divided by 15, which is equal to 0.1 amps. So 0.1 amps is the total current of I2 going through it. We know that the current through the 10 ohm is also 0.5. Therefore, the current through this 10 ohm, which we'll call I3, is equal to 0.05 plus 0.1 is equal to 0.15. Using Ohm's law again, so this will be plus minus V3. V3 is equal to 0.15 times 10, or 1.5 volts. Then that gives us an input across A, and I'll call this C. This gives us our input that will give us a 1 volt output. So therefore, it's the Vin is equal to V3 plus V2, which is 1.5 plus 1.5 is equal to 3 volts. Therefore, VO is equal to 1 volt, and the input that gives us that is 3 volts, which implies that VO over Vn, which is our K, is equal to 1/3. Now here the schematic shows us we have a 5 volt input. So the output is just simply 1/3 times 5 volts. Since this is still a linear circuit, so this is 1.667 volts as our output for our 5 volt input. A unit output of 1 volt, and we work our way back to see what input gives us, and we found that it was 3 volts will give us a 1 volt output. That implies that our proportionality constant, 1 divided by 3, is 1/3. Then we can find our output for any input by multiplying it by the proportionality constant 1/3, which gives us 1.667.